Welcome to VMware's Multi-Cloud Podcast. My name is Eric Nelson, and with me today I have my co-host, David Jasso. Today we're going to be covering improving multi-cloud management using machine learning with our guest today, Jad El-Zein. David, how you doing today?
I'm doing great, Eric. How you doing?
I'm doing great. Yeah, we're back into the new year. I'm excited to have another year here today, and so let's get started.
Yeah, excited. First show of 2021. Got to get used to saying that. Hey, we have with us today Jad El-Zein. We're going to let Jad introduce himself in a second here and talk about what he's doing with VMware, but also some of his past history. It's pretty interesting. Hey, Jad, welcome.
Hey, Dave. Hey, Eric. Welcome to 2021. I am Jad El-Zein. I'm a technology director in Cloud Management BU at VMware. A little bit of background for those who don't know me. I've been at VMware actually as of December 11 years. I've been in this industry about 24 years. I was a customer for about half of that. And today, what I focus on a day-to-day is really the VMware Cloud Management portfolio, the emerging technologies, the adoption and understanding of those emerging technologies like machine learning. And I also manage a small team of ML developers called the Advanced Development Team. I'm looking forward to this podcast. Appreciate you having me.
Cool. Yeah, we're gonna focus on this podcast around IT operations management, application management, infrastructure management, those kinds of topics, and looking at ML. But maybe we can, before we get there, just back up and spend a few minutes, not a lot. And I know a lot of people have heard about AI and also ML, but maybe give like a quick 5-minute tutorial. It doesn't even have to be about what ML is and how you think about it. And then maybe some examples and sort of very common to people, sort of more probably consumer oriented. Then we'll jump into the topic of operations.
Sure. Well, maybe because this is a relatively new topic, well known, but new at the same time. And it's actually a catch-all in a lot of cases. And actually the catch-all terminology is AI, right? The artificial intelligence component. And we've seen AI on slides. We've seen AI on ads and sales pitches and all that. But what we are really talking about today is specifically around machine learning, neural networks, the algorithms, the data science, and we'll start peeling that apart throughout this talk. But from a high level, I'll start with what it isn't. It's not robots. It's not machines doing your job. I guess they could, but that's not really the intention from a cloud management perspective. It's really, I like to put it in this perspective. If you rewind VMware 15 years ago, right, when we had like the small tiny teams going out there and explaining virtualization, and it was about all this value you can gain by virtualizing, going from physical to virtual, and what that actually means from a value perspective, right? It's money in the bank. The more you virtualize, the more you consolidate it. That was money in the bank. And our customers, they could easily see where that value benefit is. Then you fast forward and more virtualization occurred, higher levels of consolidation. And anybody who knows me and my background, the next big step was automation, right? And so we'd have these conversations with our customers that say, hey, I'm highly virtualized, right? Or I'm fully virtualized. So are you telling me now that there's no more savings to be had? And the answer from VMware was, no, let's automate. So vRealize automation and a lot of the other automation portfolio tools that we have across the business. That was, again, money in the bank because I automated. I was able to replace very expensive manual human cost. So those folks can go and do more productive things while automation handled the repetitive stuff.
Yeah, and just to sort of like to put that in context, a lot of that automation, starting to happen at the same time that cloud was coming into the marketplace as well, right? So like people could see what automation meant, this whole notion of self-service and, instant access to resources, those kinds of things, right?
Yep, exactly. And just like how virtualization became really no longer an option. It was a requirement for business, right? Automation has also hit that threshold now where you have to automate for you to be able to keep up with the demand, the line of business, the developer requirements, and of course your business requirements. And automation has been mainstream for several years now. So then you come back to the table and you say, well, now what, right? Every business, every one of our customers is looking for ways to streamline, whether it's because of stressed resources or because you've got a business that's just going out of control, especially when you have something crazy like 2020 hit and everybody has to think of new ways to do business. Automation played a big role there. So the question to now what is, let's double down on automation. And instead of being the people involved in the middle of creating those workflows, those pipelines and all that automation, this is where we can start looking at technologies and emerging tech, which is now more affordable and available to us, such as machine learning. And so with ML, to answer your question, this is really leveraging data science, which has been around for decades, and some select algorithms and a lot of internal development and IP to be able to optimize, automate, and manage infrastructure in ways that is just either too tedious or not very cost effective for humans and your practitioners to do on a day-to-day basis. Again, it's about optimizing the person's job workflow, right? And being able to do more with less. And that's just an ongoing theme. So what we're doing specifically with ML, without going deep into what ML is essentially using those capabilities and those technologies to take automation to that level where it's essentially self-driving. And you've heard self-driving from VMware for a couple of years now, but what we're talking about here is this closed loop of automation, learning, experience building, and churning of data and analysis to then go and invoke an action, and you rinse and repeat, and you keep doing that. And it's really that ML that's doing that in the background under this AI bubble. And what we'll talk about today is how this is impacting day-to-day operations and day-to-day cloud management, and what it's going to do to impact the industry as a whole. And we'll dig a little bit deeper.
Yeah, I think maybe you could just, again, I think people are familiar, but they're not, everybody hears about machine learning, but it's sort of like, what are the fundamentals? I'm thinking more around the notion that you have a model and you're trying to train a model, and maybe you can, talk about sort of that aspect. Again, not going deep on it because we're going to then look at that in practice, but sort of like the conceptual model of how ML works, basically.
Yeah. And I have something to add there from a question perspective, which is there, I've heard of self-driving since 2001, right? Like back at Sun Microsystems where I was working, like we had self-driving concepts, but it was kind of like concepts, but the technology hadn't caught up, right? Like somebody had a vision for it, but then, it turns out to be a lot harder, and you actually need the technology to mature around AI and machine learning concepts, right? And then real databases, real constructs, real languages. And so maybe talk a little bit about the maturity of the software that's come to be now, where Tesla's pushing it, everybody's pushing it, there's industry standards for it now, there's frameworks for it. Maybe expose us to like how this is matured to the point where now it's ready to actually be developed and implemented and put into production.
Yep. Yeah, absolutely. So at a high level, again, I go back to AI, and AI, we're sticking to high level here. What artificial intelligence has always been, and was always intended to be, is using software, using machines to replicate the way the human mind works. And that's where this learning concept keeps coming up, right? We learn when we go on to the next step, we apply what we've learned to be able to execute that next step. And AI leverages what's called a neural network. Well, not all AI, but in the topics we're talking
machine
about.
Learning, right, for sure.
Yeah, we're leveraging neural networks. And again, we're looking at the analogy to the human brain, neural networks. And the way this works conceptually is that we have, so we have AI, we have machine learning, we have data analytics, which has been around as long as IT, right? And analytics is that math. It is the crunching of numbers that heavily supports machine learning. And then we have big data, and big data again is another one of those token bingo card words that we use. And big data drives analytics, which is fed into ML, which fits the overall bubble of AI. And it's all kind of bunched together, but they're very uniquely contributing to the overall cause and what we're trying to do here. So, very high level. Let's talk about the algorithms themselves, which is really all where the magic is at. From an AI perspective, from a machine learning perspective, from self-driving, we needed to look at what customer problems are. We talked about self-driving and automation, and we needed to take the appropriate approach, right? Well, what VMware doesn't want to do is just throw ML and AI all over our slides and say, this is all analytics powered. We've done analytics for as long as we've had a portfolio. But really what we want to do is, what are the true customer problems? And what is the reason why this hasn't been adopted already? So first of all, the adoption rate is largely due to trust. It's largely due to cost, the infrastructure to really start getting value. Racks and racks of GPU and building these neural networks. That's not something our typical customers are going to go off and do. And then the problem statement, right? The problem is these day-to-day things I talked about, which are largely becoming more automated, but even then they're tedious, they don't scale, and there's a lot of misunderstanding of how to operate infrastructure, especially with these modern applications and crazy scale and modernized multi-cloud infrastructures. And so our take, which started a little more than 2 years ago for this specific project, what used to be called Project Magna, was how do we leverage machine learning, specific algorithms, or which algorithms should we build on top of to go and accomplish some of these tasks? Optimization, repetitive operations, understanding infrastructure. And so from an ML perspective, we lean heavily on experience. So that reinforcement learning, and in fact, the capabilities that we've started to release out there are largely based on reinforcement learning. And so what we want to do is, so we leverage reinforcement learning, and we look at a customer's environment. And I'll just walk you through a scenario. Maybe that will better describe this. So what reinforcement learning does is we go in, we collect all this data. That's the analytics. That's the big data. And some data is bigger than others, but it's huge pools of data and data lakes. And we analyze that data based on the algorithms that are being used. Specifically, or specific to each use case, we're looking for, we're looking for KPIs, we're looking for metrics, we're looking for time series data, logs, whatever it might be, but it has to be rich, clean data, or it has to be cleansed in process. So then we analyze it based on what our desired outcome is. And we have tools to measure things like, what is your current operational state? What is unique about your environment? What is the need? Right? What is your service level objective, for example? And then what is that based on the key performance indicators that I'm going to now measure against? And let's just say optimization is the case here. That data is analyzed. And then what we do is we look at ways to help you reach your goals. That is the entire existence of what we're doing, is to help customers meet their operational goals. That's basically, and if we can't do that, the value is null. Go ahead.
I was going to say, maybe we can throw something at you, Jad, because I think I agree 100% with you in terms of like sort of what ML is, and in terms of reinforcement learning and those kinds of things. One of the things, like what computers enable is to sort of like learn from things you didn't do almost, right? Where it's like you can have all these scenarios, like at any given time, if you're a person, you have to choose a path, and you don't get to sort of pick all your paths, the possible paths. You pick a path, you move forward, and maybe you learn something from it, you don't. But with machine learning, the attractive part is this notion that at any given time, I can spin off like a million alternate universes, right? And say, what if I did this? What if I did that? And you can run through all of that and then compare the results. Like what happened if I spun off at a point in time, like 1,000 alternatives instead. If I do these things, what happens, right? And you can then say, which one made the world better, right? And sort of like, and I think we're trying to do a lot of that, right? With
absolutely.
operations.
You're beating me to the punch. So absolutely, that's the case. And in fact, that's our special sauce that I'll explain a little bit more. So, once we've collected this data, one of the things we're very able to do now is analyze it over time. And we've been doing things like, predictive outcomes and all this stuff for a while. Analysis just is a pretty big bucket of all kinds of capabilities. But when we're able to do what you were just talking about, which is take everything I know, what we will call supervised learning, right? Everything I know. So take an SDDC stack, for example. There is a lot VMware knows about that SDDC stack. We know how to optimize it. We know how to install it and configure it. We know what best practice is, and we know what good and bad is, and what broken and not is. And but what we don't know is exactly how it's going to behave when 50,000 different customers install it, from customer to customer to customer, because we don't have every possible combination of workload and application and stress and everything that happens. So what we do is we ship products that are optimized for the whole. But these are like German cars, right? When you drive a car off the lot and it's got its spec and you're buying it for that, for everything it has to offer, what you can do afterwards to tweak it for your behavior is what makes that car so special for those who do that. This is the same concept, right? What we need to be able to do now is say, once I'm installed, how do we use machine learning? How do we use our neural networks to be able to build these models based on the unique operational characteristics happening in that environment on day one? The moment you start taking it outside of the out-of-the-box configuration, and then how do I then respond to optimize and operate that environment that is very unique to the applications and the business line of business that's consuming it? And you touched on it, or you hit it directly, which is to be able to do that today requires us to do a lot of basically blind testing. So that's supervised learning. That supervised learning is everything we know. Then there's this blindfolded learning, what's called unsupervised learning. Unsupervised learning is, okay, well, now that I've seen, now that I know, what don't I know? And this is where we start crunching numbers and understanding behavior and looking at patterns and doing all kinds of great things. And that's then applied or appended to everything I do know. So now I have a better picture, right? I can go in a room with a blindfold and basically feel my way around the room. And I could probably then come and draw that out for you based on just my memory, right? Without the blindfold. I don't think I'd draw it with the blindfold. Then there's a third part of that, and that's the reinforcement learning. And the reinforcement learning in this particular use case is now saying, okay, well, here's everything I know and don't know. Let me try a whole bunch of things to see what works. Now, we can do two things. We can hit your production environment and try a whole bunch of things. Not realistic. This is why you have to take the cost of building identical environments for test dev or pre-prod or staging. And you can't do that in production, especially when you're getting under the covers and getting very intrusive or experimenting with parameters and knobs and levers that can potentially impact the workload. So what we can do with reinforcement learning and this technology and everything we know and don't know is we do what's called a digital twin or sidecar model. Just like you said, we take all of this environment and we build a digital model of that environment. And that ones and zeros replica of your production vSAN cluster, for example, is now free game. And then we can take this action framework, and this is the automation piece, and says, what if I do this and a combination of these and this parameter versus that parameter, and potentially, at the scale of SDDC, tens of thousands of combinations, all done in a digital twin or any number of digital twins. And I'll measure the outcome of every single change or attribute or manipulation or parameter. And I'll say, hey, does this help me? So I'm looking at the KPI. Does this make anything incrementally better to help the operator get to their goals, their SLO? And when I find one, even if it's small, I confirm it. That model is built and applied. And when I say applied, I've already confirmed and predicted the outcome of this change in a digital model. And I could go and apply that directly into your production environment. I measure the result, I compare it to what I modeled, I rinse and repeat. This is continuous. This happens in ways that become very unique to the customer. And we leverage several neighboring technologies too, like transfer learning and several other algorithms, so that we can understand that if I were to then throw on another host in a cluster, or actually scale out my cluster, or add more hosts, or do whatever I need to do, I could apply everything I've learned immediately, so that my time to value raises very quickly. And so that's where self-driving, that's actually the exact scenario of what we're similar to what we're doing for vSAN optimization, for example.
Cool. I had a question, and Eric jump into. I mean, it's like I really sort of gravitated to this notion of digital twin because it's almost like science fiction, right? It's like, what if the sort of answers this? What if I could run, multiple alternative universes, right? What happens basically? Is it one digital twin, or is it like, because I almost think it's like, are we just spinning off at any given time like thousands of digital twins, or is it like, how does that work basically?
So it really depends on the use case, but where we can in like the basics, right? We'll create a single replica of a digital replica of an environment and start there. Because the thing is, when we go through these scenarios, we could very rapidly, revert parameters. We could go back to zero in every single change, or we could just hop from parameter to parameter, or dozens or different parameters, and test the outcomes each time. Because remember, this is done on a neural network. Mm-hmm. It's not done on premises, and it's not done at the cost of the customer. That lives in the vRealize AI neural network. And so if that can be done in some use cases in a single digital twin, it'll be done in a single digital twin. Where the vision of this thing goes, where reinforcement learning, by the way, reinforcement learning isn't like the exclusive go-to capability that we're putting out there. That happens to be this first use case. And there's actually a few others coming out where reinforcement learning is front and center. So where there's going to be needs and scenarios that we can build parallel environments to test maybe scenarios that scale beyond the single digital twin, sure, we could use multiple. It's all software, right? It's all software and resources that get eliminated when I'm done, get maintained, get reset to zero. There's a lot of good that can be done.
I think you answered my question, because I was thinking each digital twin is like its own experiment. But the way I now understand it, the digital twin is just a sandbox which you run multiple experiments in, basically, right? Kind of continuously, right? And then you use that to then apply to the real world. Okay, cool.
And
Chad.
Yeah.
Yeah, I got a question, but which is, when you're looking at network analysis, I look at the dynamic nature of my data center sometimes, where there are just things out of bounds that I can't really predict. And I'm just wondering in AI and machine learning whether we're making progress when we're looking at networking or security, for instance, where you're looking at patterns and then you're dynamically determining what to do based on recognizable patterns or things that you're learning that shouldn't be happening or should be happening, and then making adjustments accordingly. Because as an IT guy, I can't be watching it 24/7, and yet I need the ability to solve these problems.
Yeah, and you're touching on a much bigger problem as well. First of all, vSAN, the example I'm using here, is heavily network dependent, right? So how do we optimize vSAN and ignore the network? You basically can't. Right. So a lot of the early testing had to say, well, if I'm having a storage IO problem, for example, what does that mean for the network? Do I sit there and troubleshoot spindles? No, right? But the human might. The human might look at their per disk metrics or some other metric, right? We need to say that actually the problem for this app on this host is that there's a downstream MTU misconfiguration. And I have to have modeled that to understand that. Now, there is a more interesting part to this, and that is a piece that we haven't announced or released yet, but it's part of our vision, and that's been put out there. and that is network optimization. Pure network optimization as the second phase of SDDC optimization. And here we're looking at things like round trip times, latencies, and all that. And because of this digital twin, leveraging very similar technologies, we can virtually measure the impact to things like latency and RTT based on any number of parameters changing. We could understand scalability requirements without having to scale and see it first. We can virtually scale, right? We can, the use cases just become pretty vast. But what you'll see happen over time is, so far what I've been talking about is, storage owning an SLO and networks owning an SLO or KPIs. What we really need is the application to own that KPI and the SLO being tied to the application, so that when I'm optimizing at the app level, every single component or ecosystem product that touches that application is what lives in the digital twin. It's what's modeled, it's what's optimized. And that's really the North Star. And I think we are very uniquely positioned as VMware and the Cloud Management BU, as well as some of our sister BUs, to tackle that very efficiently and effectively for our customers.
Yeah, it's interesting you bring about that whole dependency on the app up and stuff. How many times I've had to go down to a data center at 2 a.m. trying to track down something that actually resulted from something I did a month ago, right? That I didn't realize that there was this cascade of events that were happening from some thing that I did, that was totally legit, but because I can't see the whole picture, monitor, and have like a whole AI engine in my head, I thought we were good, and then slowly we weren't. And then I'm now trying to figure out why, right?
Exactly.
Yeah,
exactly. And that figuring out why is the hardest part, and it happens to be where we focus. And this is called the explainability part of what we're doing. We've taken a lot of time and investment to focus on explainability. And this is something that I think has impacted general industry adoption of these types of tools. It's that no practitioner, and I know when I was the person responsible for this stuff, no practitioner wants software to take over their day-to-day, not because I'm afraid I'll be out of the job, but because I need to know what's going on. I need to explain to somebody else why things are good or bad. I need to selfishly take credit for it. So what we spend a significant amount of resources on is being able to explain every step of the way, what happened, why it happened, the scenario written around that, down to the KPI, how it impacted your KPI, and what your overall happiness is or should be at this point. And we take, and that's had this gorgeous UI experience. I just want to be able to look at a dashboard and not have to drill in, not have to do anything after I enable this thing. I just want to say things are good, things are happy, things weren't happy, they are now happy. I could use that to maybe reverse engineer and troubleshoot, but the point is it's already been fixed. I don't want to have to respond or react. I need these systems to start operating at the same operational efficiencies as I'd expect a public cloud provider to operate.
Yep. Hey, Jed, before I love the explainability UI that we have in vRealize AI Cloud. Maybe we could try to make this. We can now focus on sort of what we've already done, particularly around vSAN, and sort of talk about some of those optimizations, and then carry that forward into the discussion around the explainability UI too, because I know there's some very concrete examples we have now.
Yep. Sure. So a couple of VMworlds ago, it was VMworld 2018, Pat was on stage and he announced this thing called Project Magna, which is now been known as vRealize AI. And back then it was like this early work we were doing, a lot of science experiments really, to see, how we could best deliver capabilities to our customers and what our customers are asking for. And we landed on vSAN optimization as the absolute best initial use case. And it's based on, what I've already mentioned, is that vSAN is such a hugely capable product because it's software defined, and really what we can do with it is a lot. What we can unleash and unlock is a lot, but it is most optimized when it understands the workload that's running on it. Today, what we do is we say, hey, this is software defined. You can use storage policies. Once it's in your environment, you can optimize it for your workload. But what if the customer didn't have to do that? What if we made the recommendation for storage policies? What if we automatically optimized under the covers for the particular workloads? And so we got the green light and the R&D resources to start drilling into that. And then last year, VMworld, not 2020, 2019, we showed a little bit of a sneak peek. Then we went into beta, and then at VMworld 2020, we did the initial availability IA of vRealize AI vSAN optimization. And I've already explained my way through in explaining ML and explaining some of the concepts here. I've explained what we're doing with vSAN optimization. And it's essentially learning and experiencing, modeling, doing it in a digital twin, and doing this continuously and uniquely for a customer's environment. And that product is available as part of the vRealize Cloud Universal. It's vRealize Cloud Universal customers get vRealize AI. So it's our initial deliverable, if you may, part of something much grander, much broader, which you'll start hearing about more this year, and then of course our launch season at VMworld, a lot more exciting stuff. But it's been a big hit. Every single one of our beta customers said they would absolutely deploy this in production, just based on their beta experience. And that explainability UI, that gorgeous UI, is a big reason for that, right? Customers don't want to sift through dashboard after dashboard, and then have to gather and correlate data and then determine how to respond. And we've done a tremendous amount of work in our portfolio to help that workflow happen. In a lot of cases, that should have just happened, right? And I should just tell you what the result is, and that's it, right? And then we use our operations tools to operate the environment, and vRealize AI does the continuous optimization work.
So we started with vSAN, so storage. Then where do we go from here? What sort of things would we look at next?
So I kind of hinted on it. The thing that customers are seeing now roll out is what's called the SBMM Genie. So for the vSAN customers out there, storage policies or storage, the SBMMs that we use to create storage policies that you could apply to your environments and optimize based on your preferences. Those are, again, a hugely powerful capability. It's software defined. I can define things like availability and RAID and performance and caching and reservations and all this stuff at the storage level with vSAN. We've done some analysis, some back-end work, and spoke to a ton of customers and realized that while hugely capable, the SBMMs aren't as widely used as you would expect it to be based on the impact to the environment, because customers don't really understand the outcome. Well, if I could model that outcome for you and in fact make the recommendation of which SBMM or which policy will best suit the needs of your vSAN clusters, well, why not? So that is the newest addition to vRealize AI, and that's the SBMM Genie. And we explain it again, the explainability UI, and being able to go in and tell you exactly why this decision was made based on the data we see and the experiences we've had in your environment. And that has gotten a lot of attention from our design partners and beta customers, because it will truly unlock and help accelerate the use of SBMMs. So now we have two complementary capabilities: this under the covers continuous optimization, self-driving, and SBMM Genie that says this storage policy will best suit the needs of your environment. Then you complement them, and we're, the continuous stuff continues.
So what's the storage policy? What's the BM? What's the
based management?
Okay.
Yeah.
Storage policy based management. Okay, cool. Sounds good. Eric, anything before we transition to sort of what's next for Jad and folks? Oops, I think Eric's frozen. Jad, you're still there, right?
Yeah, he's either enthralled or frozen.
He's frozen, I think. So let's. Why don't we? He'll probably come back or come back in or something in a minute here. And but why don't we Let's just wait and we'll repeat that piece of it. So he drops, they'll come back in. Let's hold on here. Julia, you there still? She might be, I don't know.
Yes, I'm here.
Yeah.
So we lost Eric. We're waiting on him to come back in.
Let's keep recording, give him a few minutes. And
All
when
right.
he comes,
I will give him a few minutes. If not, I will keep recording because we're almost at the end of it anyway.
Yeah. If he doesn't come back, we can just wrap up you by yourself.
There he is.
There we go.
All right. So I think we lost you somewhere around. Let's pretend we lost you because we didn't really know we lost you.
Yeah, no, I heard. I did have one.
You were on. I know you were on. I just
I had
video froze.
Right. I had
Go ahead.
one follow-up question, which I thought Jad made an interesting point. I did hear all of you guys, so I was just kind of hearing, but
So
frozen.
let's start with your question. Wherever he ended, we'll pick up, and let's start with your question.
All right, great. So my question is, and it's more like a comment, Jad, which is you mentioned the beta feedback of the UI, and I find that really interesting because for me there is this disconnect between machine learning and AI, and then allowing people to somehow use it, right? And I think Alexa did a really good job of like hiding all the complexity of what's happening out in the cloud and just giving you a simple interface to engage with an AI engine. It's not kind of it's we're apples and oranges here. But I find it interesting that you guys have somehow done a really good job building a GUI that allows you to take advantage of this without the complexity of trying to figure out what you're engaged with. Because I think that to make it really work, you have to figure out how to allow people to engage with it in a productive way that doesn't get overly complicated.
Yeah. And so that's exactly right. And actually, I'm going to steal an example. So my boss, so Mike Wookie is the CTO of CMBU. He points to Ubiquity networks, and Ubiquity, for those who are fanboys and gals of Ubiquity. Ubiquity has done an incredible job, basically rebuilding their entire UI experience. And Mike always says the first thing you see when he logs into Ubiquity is everything is good, or things aren't good, right?
Right.
And Ubiquity leverages AI heavily for these networks, and I'm a huge fan. And again, not apples to apples, but it's the experience we're talking about here.
Right.
And so while we weren't pointing at that and saying that's what we want, that's just an example that others might understand. What we wanted our UI to represent isn't what you can do, it's what you didn't have to do, right? Right. And what you didn't have to do, in fact, it's not just what you didn't have to do, it's what you didn't know you had to do, right? Or you didn't know you didn't have to do, right? But for those like me and a lot of folks watching this, you probably at least want to know what happened. And so while I can tell you everything is good, or I can tell you you've improved in this way, I also want to show you here's exactly what's happened. And I think that's critical, not just for that peace of mind, which is, in my opinion, kind of a roadblock for mainstream ML operations adoption, but it's also, I need to be able to explain why this stuff is valuable to my peers, to my leadership. And I need to be able to explain why things are going so well or not. And then I have the rest of the CMBU portfolio to help me to dig in where needed. And in fact, if I can't optimize, we actually call it out. Here's why this host isn't optimizing like the rest of the other hosts, or this app isn't optimized. And then we can point you into the operations tools for the break fix piece. Now, long term, hey, self-healing is certainly around the corner, leveraging these capabilities.
Yeah, I like, there are a couple thoughts on the UI. I've seen it from the demos and things you guys did at VMworld. But like you said, it's not what you should do, right? So it's not a UI to go in and figure out your algorithms and things like that. You've already done that. And in the digital twin, you're applying those. And what the UI shows you is, hey, here's all the things that we found that really made a difference in the digital twin, basically, right? And here's how we applied them, and here's the incremental improvement each one of those things got you, right? So you can see, oh, I got a little bit from this, a little bit from that, and things that, the way humans work, you never would have done because they're so fine-grained often that a human wouldn't have found them. It's like they're just like, you wouldn't have come up with those things. You said, or you would have come up with them and said, oh, that makes such a small difference, I'm not going to do it, right? But it's like when you add up all the things you found in the digital twin, they can make a huge impact, 50% improvement in performance and things like that, right? That's pretty cool.
For me, this stuff also becomes really important. It's easy to ignore it because I've run data centers and I know what I'm doing. And it's all great. And, we put in new machines now and then. But when you start talking about modern apps, right, with microservices, and you're breaking the apps apart and you have these interconnects that are happening from service to service, it starts becoming harder to just say that, oh, I can get it, I know what I'm doing. You really actually need a smarter engine out there to be able to allow you to transition. And, Kubernetes is, what we're all digesting now, right? Our classic IT admins like myself, guys are coming and going like, okay, I get Kubernetes now by just upgrading to vSphere 7, but like to manage, now in modern apps, and I'm going to deploy my first set of them. And now I have to have a management framework and an AI framework that's actually keeping track of the applications and the application dependencies. That becomes something that you're just not going to do on your own.
Yeah, I think I was just add a comment to that, Eric, because I think we've moved past the zone of a nice to have for AI and ML to a must have, simply because the scale of operations is so much bigger than it used to be. You just can't keep track of it as a human.
And Eric touched on it. Complexity is key. And a little tidbit here, 2 years ago, this whole effort started with Kubernetes optimization.
Right.
And so we basically experimented at our ultimate goal. Now we're kind of building the foundations to all that, and we're going to end up at the application again. And Eric, like you mentioned, the complexities here are just not manageable anymore, right? Kubernetes is not as easy as it's said to be, and it's not just Kubernetes, but the entire application stack and the complexity of the infrastructure and the ecosystem and the dependencies and the upstream
endpoints and
impact of any given change. And this is the answer to our customers that say, how do I run at the operational efficiency of this public cloud provider? Because we're seeing this full circle happen where the private clouds are coming back, and this is it. This is how you have to operate in this next gen world, and we're answering the mail on that.
Yeah, that's what I learned. I put Kubernetes on Raspberry Pis, and I built my little cluster, and I have a cluster, and then I built little Raspberry Pi sensor apps that we were controlling through Kubernetes pods. And I was, it's like, but even those simple things, you're starting to look at how many dependencies I have on things that are in the stack, that are in these layers, and you're like, yeah, if I were going to do this in a big production environment, you just need to start with tools, and you need to start with AI, and you need to start with endpoint management. It's like, this becomes something that, as we all learn Kubernetes, vSphere 7 and Spherelets and being competent as IT guys and architecting this, this is just like Dave says. Dave, you said it right. It's now a must have as part of this next solution that we're going to all start to work with.
Exactly.
Cool. Hey, I think it's a good discussion, Jad, on ML and how it's impacting operations management and application and infrastructure management. Maybe you can let our audience know sort of how they can learn more. I know you guys did some of the stuff for VMworld. I think it's still up. I think VMworld stuff is still up.
Yeah. Yep. So there's a couple of sessions specifically on this topic. One more industry high level that myself and Mike Wiki put out there. And then there's one where I drive into vSAN optimization primarily. And in there, you're going to learn a lot of what we're doing. I highly recommend, obviously, watching those videos. But we've only scratched the surface with optimization, right? And so be on the lookout for a whole lot more coming this year. We're expanding into diagnosis. And we're expanding into prediction, leveraging ML and these neural networks, heavily into explainability. And instead of just focusing on each of these as a domain, like network optimization and storage optimization and placement optimization, all this stuff, we're talking about a system that's designed to intelligently work together. And so incrementally, that's our goal. And the app is going to be king. So keep on the lookout. I'll be a little bit social about it on that virtual Jad, but between now and VMworld, certainly a ton will be coming out. And there's a few URLs that are available for more information today on how to get more information. We'll post those.
Cool.
Very cool. Very cool. Yeah, great to hear about this. I'm excited about it. In my take, I'll have another comment here. So as long as it's a podcast, we get to chat a little bit. I would say that I spent the holiday moving some of my workloads off of Amazon, right? Because you go to Amazon because of speed and the ability to just do it, right? And then you slowly start getting your bills, right? And then you start looking at checkbox items that you want to bring back on-prem, because I have a rack in San Jose. I have some things we run, like gaming servers, things like that. And eventually you go like, this is costing more than, a machine would cost me, if I just put it and set it up, rent it, and, like I could put a whole vSphere instance of it, do that. And you start realizing you really want it on-prem, right? Because of just the cost, right? Purely cost, but yet you want the simplicity of, and we put our workloads on VMs. I have machines with VMs running, and you want that simplicity of what you got in the cloud, right? And you want the reliability, but you just know that you're not going to keep those apps up running, and getting that bill, right? And so,
and then some. Keep in mind that most cloud providers won't tweak their back end based on the needs of your application.
Right.
Very generically, peanut butter spread, right?
Right.
So our one-up on that, for especially, when we see this demand coming back to the SDDC and VMware Cloud and VMC or VMware Cloud on-prem instantiations, is that we don't want to just say, okay, well, now you're equal and you got what you want at the efficiencies you want. Now it's like, and then here's some added benefit. It is unique to you, and it's continuously made unique to the very actively changing needs of the environment and the application. So we feel that, and of course, this becomes part of a much broader multi-cloud strategy that every one of our customers are looking at. And we have a lot of really great ideas being put together for that as well.
Yeah, I think every business has their own uniqueness around bringing their apps back or having their apps on-prem, right? We had our own uniqueness of why we wanted to do it. There was price, but there were also other things that we wanted to do, build into the app, that we wanted to, have it on-prem versus, out floating in the cloud. So I think everybody has their own uniqueness, and certainly VMware, even though, I work at VMware and I want to say that, we're the added value, that we give you better infrastructure than they do. The reality is we had other reasons that we also wanted to bring it on-prem, right? So everybody has their own, but it's good that VMware is also able to add additional value. Right.
And we shouldn't forget also that as we, bring the SDDC into the hyperscaler clouds, that these same technologies will be running there too, to optimize those environments. So that's important.
Cool stuff.
Yeah, good stuff. So anything else you think, you talked a little bit about what you're doing for the balance of the year and around AI, anything else big you want to mention?
We have a very ambitious portfolio and a development cycle, and again, lots of really great things coming out this year. Of course, the big splash will be at VMWorld, but it's rinse and repeat. We have a multi-year strategy here, but I think it's been very exciting, very unique capabilities. Something that we at VMware take for granted is our position and what we can do for our customers because of that, right? And this is exactly us doing this. So we focus on that, and it's kept us pretty busy.
All right. Perfect.
Well, welcome to 2021, everyone.
I always end up with, I see on your whiteboard there, maybe that's a Twitter handle up in the right hand corner there. Yep. What is
Jad.
Virtual Jad?
Virtual Jad. Now don't go to my blog, because I haven't blogged since vRealize automation was automation was my expertise up until I joined Octo, and I have totally let my followers down and stopped blogging, but I'm going to reboot that thing. That is one of my New Year's resolutions. So Virtual Jad on Twitter, virtualjad.com is
all right.
Blog.
So people that are just listening to the audio, it's Virtual JAD. So there you go.
Yeah, sounds
give
like
him a
chat.
follow. Say hello. Give him a follow. Say hello. Tell him you heard it on the Multi-Cloud Podcast with Eric and David. Cool.
Yeah. All righty. Thanks, everyone.
Thanks,
right.
everyone.
Thanks
See you
all. Thanks
soon.
for having me. Always a
Yeah.
pleasure.
All right. It's good having you.